Hi everyone. Next we are moving to the another part 3 video lecture number 3, not gate. Okay, in this particular case, not gate, see, this is a symbol for not gate. Still now we look at AND gate symbol and OR gate symbol. This is a representation for not gate. So not gate is called it is called as a, because why it is called as a not gate, output is not the same as input, that's why it is a not gate. For example, you are given 1, okay, you will get the output is 0, that means output is not as a input, that's why it is a not gate. So it is represented by B is equal to A bar. What is the representation? B is equal to A bar is a representation for not gate. So not gate is also called as an inverter, because it is 0, it is converted into, it is 1, it is converted into 0. If it is 0, it is converted into 1. It is like as an inverter, because it is inverts the input signal. It is a one input and one output. It is also in the examination they will ask one input and one output, which gate is there. They might be question options: AND gate, OR gate, NOT gate, and none of the above. NOT gate is option, only one input, only one output. Okay, that is the speciality of NOT gate. So this is the truth table for NOT gate. It is 0, it is 1, it is 1, it is 0. So the logical symbol for inversion or negation or complementation of a bar over a function, it indicates as the opposite state. That means B is equal to A bar is nothing but this bar is represented as either inversion or negation or complementation is a bar. This particular bar is a function. So it is indicated as the opposite state. Okay, for example, like 0 bar is nothing but a 1. Actually it is 1. 0 bar is nothing but opposite to that. Okay, next we are moving to the equivalent circuit for the relay. By using relay, how to draw the equivalent circuit for NOT gate. So you know, in the NOT gate only one relay is present, that is A. Whenever A is equal to 1, for example, this relay is activated, it is attracted. Whatever may be the output that is available, whenever it is 1, it is attracted. Whatever may be the 5 volt, okay, this 5 volt is grounded. That means it is directly connected. What about the output available here? Whenever it is normally closed, it is 0. Whenever it is 0, for example, it is 0, this relay is deactivated. This relay is not attracted to that. That means this 5 volt is appears across this particular resistor. That means output B is equal to 1. Got my point? This is about the equivalent circuit of a NOT gate working principle. Next, coming to the transistor, it is a simple, this is the representation for NOT gate. If A is equal to 0, for example, this particular transistor is a cutoff region. Wherever this cutoff region, you know, what amount of voltage 5 volt present here, that will be available here, that will be equivalent to 1, high voltage, the high value. Next, whenever A is equal to 1, that means this is a activated, this is, it is a on state saturation. Whenever it is on state, it is like a short circuit. That means this 5 volt is connected through transistor, it is grounded. What about the voltage present here? It be 0. Whenever it is 1, it is conducted, output is 0, because it is create the path for ground. Got my point? Inversion, whenever 1 0 0 1, that is about the equivalent circuit of transistor. Got my point? So all these explanation for theory explanation, what exactly it is. Okay, clear? Next we are moving to the NOT operation in the logical manner. For example, NOT gate connected in series, what will happen? For example, two NOT gates connected cascaded. It is A, output is A bar. Again you are connected A double bar. You know, according to A double bar, both the bars are cancelled, will get A. That means whenever two NOT gates are connected in series, you will get the input is same as output. Okay, that is a dual complementation gives the original value. So now this is the end of NOT gate. Now we are going to discuss about the examples of NOT gate, AND gate and OR gate. Okay, all these examples. So the first example, find the Boolean equation for the output D shown in the figure. This is the D when equivalent to D is equal to two cases. The first case, A is equal to 0, P is equal to 1, C is equal to 1. I will explain here. A is equal to 0, right? B is equal to 1. AND gate, 0 into 1, 0, AND gate. So here 0 is present. Next C, 1. Now it is a OR gate, 0 plus 1. According to OR gate, 0 plus 1, 1 only. So what is the output D? 1. So that's what your explanation. Okay, D is 1. Next, second, we are moving to the second bit. Okay, in the second bit, now A is equal to 1. Okay, B is equal to 1. Whenever both are 1 and 1, the AND gate value is a 1. So what about the input terminal? 1 is present. Next, C, 1. Already here 1 is present. According to OR gate concept, 1 plus 1, it is equal to 1. So what about the second bit answer? 1 only. Okay, clear? It is a very simple. Once you know the basics, maybe examination you may expect this type of questions. Okay. Next question, example 2. Find the Boolean expression for the output of figure A in the two cases. Okay. Let us discuss the first case. In the first case, A is equal to 0, B is equal to 1. It is a OR gate, right? So it is a 1 plus 0, 1. It is a C, it is a 1. It is a AND gate, right? In a AND gate, 1 into 1, according to truth table, it is a 1. Clear? So first bit is a 1. Okay, right. Next, coming to the second bit. In the second bit, it is 1, right? So let me take another color. It is 1, right? B is 1. 1 into 1, according to AND gate, OR gate, it is OR gate, right? It is 1. 1 plus 1 also 1. It is AND gate, right? It is 0. 0 and then here 1. 0 and 1, AND gate 0. So what is the answer? 0. So you will get 0. Okay. This is the way you need to analyze the circuits. Next, example 3. In the example 3, find the Boolean expression for the output shown in the figure A. Okay, you need to identify the output. A, B, C both are 1. So 1, 1 and 1. And then D is 0. 1 into 1, 1. Here 1. 1 into 1, 1. Okay, here 0. 0 into 1, 0. Got my point? So output is 0. Finally, whatever it may be the circuit we have, you know the truth table of every AND gate, NOT gate and OR gate, you can analyze any circuit. Okay. Next we are moving to the question number 4. Example 4. In the example 4, shown in the figure C, output C you need to identify. The first case, A is equal to 0, B is equal to 1. So let me take black color. A is equal to 0, P is equal to 1. What about the output? A is equal to 0, this is the NOT gate, right? That means he will get 1. It is 1. It is a OR gate, right? 1 plus 1 in the OR gate, it is a 1. 1 plus 1, 1. So that is the first case answer, 1. It is okay. Next, second. In the second case, you know, A is equal to 1, B is equal to 0. Whenever it is a 1, you will get 0 here. It is already 0. 0 plus 0, 0 only. 0 plus 0, 0. So 0 is the answer. Okay. Next we are moving to the example 5. Okay. Example 5. Look at here. The first question. According to the shown in the figure, find the output C. A is 0. B is 0. Whenever A is 0, what about the output here? 1. It is an OR gate. It is a B. It is a 1. It is a OR gate. 1 plus 1, 1 only. So you will get 1. So see here, it is 1. Okay, directly do the, because you are attending the objective exam, directly can do the answer in the examination. That's why actually I gave the procedure. This is the procedure, but you need to attend the competitive exam, right? That's why I will directly explain to you. Next, A is 1 and B is 1. It is 1, it is 0, it is 1, it is 0. 0 plus 0, 0 only. Okay, we'll get 0. Okay, we'll discuss one more example and we'll end this lecture now. Okay, write down the Boolean equations for the output C of the shown in the figure. They are given 4 cases. Each and every case we are going to discuss. The first case, let me take A is 0, B is 0, it is 1, it is 0, it is AND gate. 0 into 1, 0 only. It is NOT gate again connected. Here 0 will get 1. Okay, this is the first example. Look at here, it is 1, right? Next, second. In the second case, it is 0, already it is there, it is 0, it is 1, it is 0 is nothing but a, here 1 you will get, it is 1 is nothing but a 1, and get 1 into 1, 1 only, 1 inversion, 0. Got my point? So second option, 0. Third, in the third case, A is 1, B is 0, right? A is 1 here, you will get 0, B 0, 0 into 0, 0. Whenever it is 0, it is NOT gate, you will get 1. Okay, in the third case, you will get 1. In the last case, A is 1, B is 1. It is A is 1 is nothing but you will get 0. It is 1. 1 into 0, 0 only. AND gate, right? 0 negation 1. You will get 1 here. So you will get 1. Okay. Finally, this is a explanation about this particular NOT gate and examples. In the next class, we are going to discuss about the universal gates. That is a NAND and NOR gates. After that, adder and subtractor, parallel adder, remaining half adder and full adder circuits in the next class. Okay, thank you.